In this video, what I want to do is I want to look at the input resistances that is seen by the inputs V1 and V2 when they are applied to the differential amplifier that we looked at in the previous video. So let's just start off by looking at V1. So suppose we have a voltage source whose value is V1 and we apply it at the input of this differential amplifier. So the question that I'm asking is, what would be the resistance that this would see when it looks inside the differential amplifier? How are we going to find it? To find out the resistance, so what I'm saying is I want to find out R in 1, let's call it, and that is going to be equal to V1 over I1, where I1 is the current that goes into this terminal. Okay, so how am I going to find out I1? So let's just look at the path that I1 is going to flow through. So I1 is going to flow through this resistance. We know that the current that goes into the input terminal of the op-amp is 0. That's one of the assumptions that we make in our ideal op-amp model. So this current is 0. So all the current that flows through R1 is also going to flow through this resistance. So this is going to be I1, right? So what is, so if you want to write an equation here for the voltage drop across R1, what is it going to be? It is going to be I1 R1, and then we have a voltage drop across R2, which is going to be I1 times R2. So both these voltage drops add up. So if you're basically, what I'm doing is I'm writing the Kirchhoff's voltage law in this loop. So you have V1 and then you have two drops here. So you have minus V1 plus this equal to 0, which means that V1 equal to I1 times R1 plus R2, and this means that V1 over I1 equal to R1 plus R2. You could have simply seen this by seeing that the same current flows through both these resistors. So these two resistors are in series. So the combination that V1 sees is R1 plus R2. But that's the input resistance. So R in 1 equal to R1 plus R2. Let me just clean up this board a little bit. Okay, next what we want to do is we want to find out the input resistance at the input V2. So let's just again kind of explicitly denote this voltage source here of value V2. And what we want to find out is I2. If we find out I2, then what we can do is we can say R in 2 is equal to V2 over I2. Okay. So to find out I2, what do we need to know? We have the voltage across R1 on this side of R1 already. We want to find out the voltage at this side of R1. Now this voltage is going to be the same as this voltage. And what is this voltage going to be? It's basically a voltage divider, as we have seen before. So this is going to be V1 times R2 by R1 plus R2. Right? And so this is the voltage that is there at this point as well. So now let's try to write an equation for I2. So what do we get? So V2 minus V1 times R2 over R1 plus R2 divided by R1 will give us I2. Okay, and if you want to find out, and now what we can do is we can say, okay, I want to find out R in 2, which is V2 over I2, and you can see that V2 over I2 is going to be dependent on V1 as well. Okay, so let me just write this here. So V2 and we get here, we get R1 at the numerator, and we get V2 minus V1 R2 over R1 plus R2. If we then divide the numerator and the denominator by V2, what we get is we get R1 at the numerator, and in the denominator we get 1 minus V1 over V2 R2 over R1 plus R2. Right, so that is R in 2. And you can see that R in 2 depends on the ratio of V1 and V2. Right? If V1 and V2 are equal, then then R in 2 is going to be R1 1 minus R2 over R1 plus R2. If V1 is 0, we get R in 2 is equal to R1, and so on and so forth. So basically what we are saying is that as V1 increases, the input resistance here starts to increase. Now, why is the input resistances in a differential amplifier important? As we already said, the higher the input impedance, the more chance that the circuit will not load whatever is coming before it. And this becomes especially important when you are recording ECG, which was an application which we looked at in lecture 1. So when we are recording electrocardiogram, we put electrodes in the body, and these electrodes are connected to the differential amplifier because we want to take the difference between two electrodes that we have put on the body. But because of this input resistances, they start to load your electrodes, your signal that is coming, and distort your ECG. Now we need to do something so that we can use these circuits without distortions. But that's a topic for the next video.